20 seconds. Does anyone have any questions in these 20 seconds before I dive into my spiel? Okay then. So I'm going to record these lectures and post them on YouTube. I'm recording my other 2 recitations, which happened earlier in the week. So I don't know if I'm going to continue to record and post all 3 of them, considering they contain basically the same material. But for now, I'm going to be posting all 3 of them. I'll send you guys the link to the first video that I post, and then after that, if you want, you can just check that channel. You can subscribe to it, whatever. It's just going to be the 3 recitations for the quarter that I'll be posting. What else is there? The MRC, the Math Resource Center, is the tutoring service for the math department. The hours that is available are available on the Blackboard page. I believe it's 10 a.m. to 7 p.m. Monday through Thursday, and then 10 a.m. to 5 p.m. on Friday. My hours are also up there, so if there's anything that you feel the need to come specifically to me for, you can do that, but there will be people there who are capable of helping you out with your homeworks literally anytime. So yeah, I think that's about it. There are no like specific assignments for this course or for this recitation, but you guys should try to do these ahead of time. It's no way that I can really enforce it. So, but it'll make your recitation experience better if you have some familiarity with these questions ahead of time. And yeah. And you can't go to the MRC for questions on graded assignments. Do people have any specific questions that they want me to go over on the worksheet 1? Have any of you guys actually looked at worksheet 1?
Yes.
Yeah.
Cool. So do you guys have any specific questions?
No.
Nope.
Okay, cool. Then I am going to just basically go straight through this. And my last 2, I basically exactly finished.
Oh wait, I have a question. Sorry.
Hello.
Okay.
So are we going to be like, is this kind of like a review from 101, or are we going to be like quizzed on this stuff?
I'm not actually sure what the content of your quizzes is. All of this, this worksheet is just review.
Okay, cool.
A lot of the time they'll have a review quiz, but I don't know what the deal is, the actual quizzes.
All right, thanks.
Yeah, no problem. So how am I going to find the equation of a line that passes through these 2 things? What's the first of these 2 points? What's the first thing that I do? Hint?
Slope.
Yeah, exactly. So I find the slope, which is just rise over run. So I'm just going to do that as, so in general, it's y1 minus y2 over x1 minus x2. You might also see it reversed. It doesn't matter as long as you have the 1 over the 1 and the 2 over the 2. And then that's 3 minus -1. So that gives me 6 over 4 is equal to 3 over 2. So that is my slope. Now what do? I want y is equal to mx plus b.
Plug in the previous point and 3 over 2 for m.
Exactly. So I'm going to pick the 3 and 11. You can, actually I'll pick the other one. I think I did 3 over 11 my last 2 courses. So I'll do 5 is equal to 3 halves times -1 plus b. So that means that I have, that looks like a 6 plus b. So b is going to be equal to 5, and then this becomes -3 halves. I'm going to add that to both sides. 3 halves, and I get 5 plus 3 halves, which is equal to 13/2. Cool. Does that make sense to everybody?
Yep.
Cool. Find the slope in the equation of a line that is the horizontal line passing through the point 27. A horizontal line, what is the slope of that? Someone shouted at me.
Wait, did you ask what the equation is?
I just asked what the slope is first.
0.
0.
Yeah. So I get m is equal to 0. And then if I do the same thing that I did before of y is equal to mx plus b, I plug in m is equal to 0. And plug in the 0.27, I get 7 is equal to 0 times 2 plus b. So b is equal to 7. Cool.
Yep.
Now, oh, a little bit too far there. We've got 1 over x to the 4th. What is that going to be?
X to the -4th.
Exactly. So this guy is equal to x to the -4. So the rule that we're working with here is if you've got it on the bottom of a fraction, you can just pull it up to the top and then you just negate the power. So the power stays the same except it becomes negative. This guy right here is something very similar. I'm just going to pull it out here and then it becomes the exact same principle here. And then what do I get?
2x to the -5th.
Exactly. Same idea here. And we get 5 over 7 x to the -4, right? So in these guys, these are my a's, and then obviously this is my x to the n. This is my x to the n. Here my a is just an invisible one. This one is a slightly more complicated, but still not too hard if you remember your rules of exponents. What
x to the -1/2.
exactly? But I'm just gonna do that step by step. So the square root of x is, as you can probably gather from what you just said, just x to the 1/2. So that's equal to 1/6. 1 over x to the 1/2 is equal to 1/6 x to the -1/2. Then this guy right here, what is that going to be? So cube root, the square root was to the 1/2. What's cube root?
2x to the -4/3.
Yeah. So cube root is you raise it to the 3rd, so you get 2 times 1 over x to the 4 to the 1/3. And then when you raise a power to a power, that's the same thing as multiplying the powers. So you get 2 over 1 over x to the 4/3. And then you move it up and you get 2x to the -4/3. Cool. Any questions? This does sometimes trip students up, so it's just kind of a bunch of rules that you just kind of have to memorize and until you understand what's going on. So if I want to simplify a rational expression, what is my first step?
Subtract 8. Subtract 8 from both sides.
You're jumping to 5. I'm still on 4.
You factor the denominator.
Yeah. So factor top and bottom, but the top is already as factors as you're going to get it. So so I need two things that multiply to give me -3 and add to give me -2. So the only things that add to give or multiply to give me 3 are 3 and 1. And because they add to -2, that tells me that the bigger one has to be the negative. So this is x minus 3 divided by x minus 3 times x plus 1. And generally, you're actually going to be able to cancel something, so it makes sense that you'll have something that's shared on the top and the bottom. Just otherwise, they probably wouldn't ask you it in this type of question. So these guys cancel, and I'm left with 1 over x plus 1. Does that make sense to everybody? Cool. What about this guy? What's my first step going to be factoring the top?
You would pull out a 2x from the top
Exactly.
and then factor it and the bottom.
Yeah. Okay. So this guy right here, sorry, that's -4. That is not very readable. So this guy on the bottom here, I need two things that multiply to give me -32 and add to give me -4. So one of them is going to be positive, one's going to be negative, and the bigger one is going to be negative because they had to give me a negative number. So I do 32 and 1, 16 and 2, and 8 and 4. And I believe that's all the pairs. And this is the one that gives it to us. So we get -8 and +4. And this guy, same idea. We need two things that multiply to give me -40 and add to give me -6. So that tells me that the bigger one is going to be the negative. So we get 40 and 1. We get 20 and 2. We get then we get 10 and 4, and we get 8 and 5. And it's going to be 10 and 4. So now that tells me we get 2x times x minus 10 x plus 4 over x minus 8 x plus 4. These guys cancel, and I'm left with 2x times x minus 10 times x over x minus 8. Does that make sense to everybody?
Yep.
Cool. So who was shouting at me before how to solve this guy? Someone started doing it.
Yeah, that was me, my bad.
No worries. You want to start me off on it now?
Yeah, sure. Just subtract 8 from both sides and take the cube root.
Yeah. Then cube root, so then that gives us cube root of both sides. That gives me x is equal to -2, and that's going to be my only real solution. Anyone want to try B? It's a similar idea to start, so we move the 16 over. And now we could take the fourth root, but I think it'll actually be a little bit clearer for you guys if we do the square root and then we do the square root again. So I'm gonna go through that process. So if I do the square root of both sides, then I get x squared is equal to plus or minus 4. But what happens if I do the square root of -4? What happens if I do the square root of -4? Somebody shout at me.
2.
It's
Ooh,
undefined.
Huh?
It doesn't exist.
Yeah, I get imaginary numbers if I do the square root of a negative number. So I'm just going to disregard that. I'm just going to do the square root of positive 4. So then that gives me x is equal to, someone shouted at me.
4.
We're doing the square root of 4, right?
2 and negative 2.
Exactly. Plus and minus 2. And can't forget to do both of them. If you forget to do both of them, then it is wrong. Or partially wrong. This guy. So here I'm going to start by saying, hey, what can I pull out of all 3 of these? And it turns out that I can pull a 2x cubed out of all 3 of them. So that's equal to 2x cubed times x squared plus 6x plus 5. And then I'm going to ask myself, how can I factor this guy? And that is going to be 2 things that multiply to give me positive 5 and add to give me positive 6. So that's plus 5 and plus 1. So that gives me 2x cubed times x plus 5 times x plus 1. So this guy right here, so when is this whole thing equal to 0? So when any of the component parts is equal to 0, right? Any of the things I multiply to give it is equal to 0. So what values of x make this equal to 0?
0, negative 5, negative 1.
Exactly. Or so it's any of those 3 possibilities. Here, you can try going about factoring it, but just looking at it is going to be an ugly factoring process. So I'm going to suggest you guys do the quadratic equation instead. Anyone know the song for the quadratic equation and want to sing it for me? Anybody?
I didn't even know there was a song for that.
Yeah, it goes to the.
Oh, I know
tune-
the song. I know the song.
Serenade Us.
Okay. I might get it wrong because I haven't sang it since like high school, but I'll try. X equals negative b plus or minus the square root of
B squared minus 4.
b squared minus 4ac all over 2a.
Exactly. Nice. Yeah. So it's if I had you guys in person, we would probably spend the next 3 minutes just all singing that together over and over again. But I don't think that'll work very well over Zoom. So it's it just goes to the tune of Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4c all over 2a. And you can now see that my singing is about as good as my handwriting. But so I'm going to suggest that we just plug that into this guy, or this guy into that. So we get x is equal to negative 11 plus or minus the square root of negative 11 squared plus,
Wait,
minus
you
4.
can factor it, right?
Huh?
You can factor it, right?
You can pull a 2 out, and that'll give you.
I just had 2x
Oh.
minus 3 and x minus 4.
Okay, yeah, that also works.
Okay.
I mean, you can definitely factor this, but usually when you can only get the lead coefficient out, when the lead coefficient is not 0, or sorry, it's not 1, and that means that you'll have a fraction in the middle, which this guy would become 11 halves. Usually at that point, it's easier to do the quadratic equation, but yes, you can factor it. And if you did that, then yeah, awesome. That's good for you. But I also just want to show the alternative method over 2 times 2. So we get so this guy is going to be equal to 11 plus or minus the square root of 121 minus 96 all over 4. 121 minus 96 is
25.
Exactly. So we can think of that as root 25, and we normally think of root 25 as just 5. So this is equal to 11. So I'm just going to 16 over 4 or 6 over 4. And then that's going to be equal to 4 or 3/2. Cool. And I assume that that is what you got when you did the factoring as well.
Yeah.
Cool. So what about this guy?
X equals 25.
Yeah, skipping a few steps there, but got the right answer in the end. So first thing I'm going to suggest you do is move the 10x or 10 over rad x to the other side. So we get this guy, and then multiply both sides by root x, and I get 2 root x is equal to 10. Divide both sides by 2, and I get root x is equal to 5. Square both sides, and I get x is equal to 25. So now this guy, so I only care about when it's equal to 0, which means that I basically don't really care what's happening on the bottom. A lot of the time I will care about what's happening on the bottom, because a lot of the time I'll care about like where there's a discontinuity. And if I divide by 0, that gives me a discontinuity. But as long as I don't have the same thing on top and bottom, giving me a whole discontinuity, then I really just care what's happening on the top. So when is the top equal to 0? Does that make sense to everybody? Why I don't really care what's happening on the bottom?
Yes.
Cool. So then I get 3x is equal to 1, x is equal to 1/3. Cool. How will I start this guy off?
Move the second half of the equation to the other side. X equals 7.
Okay. You mean like that?
Yeah.
Okay. Yeah, that works. That is a perfectly valid way to do it. Not the way I was thinking of, but that does work. What I was thinking is you can pull the e to the x out of both of these guys, factor it, and get that is equal to 0. E to the x is never equal to 0. There's no real number such that that's equal to 0, and I'm just left with x is equal to 7 from this guy. So what about this guy? How am I going to start this off?
Move the second half to the other side. So 4 equals ln x. And then using properties, x would equal e to the 4th.
Yeah, so then you just kind of raise e to both sides of the equation, and then you get x is equal to e to the 4th. We don't really have a nice phrase for that, but that's what you're doing. Kind of similar idea here. You're just going to move it to the other side of the equation. Divide both sides by 6, right? So we have 1/6 is equal to e to the 6x. So now what am I going to do?
Take the natural log of both sides.
Cool. So I get ln of 1/6 is equal to ln of e to the 6x. I'm just going to use the laws of logs to put that down there, and that tells me ln of 1/6 is equal to 6x times ln of e. This cancels, so I just have 6x is equal to ln of 1/6. And now what is the obvious way to finish this off?
Divide both sides by 6.
Yeah, so x is equal to 1/6 ln of 1/6. Does that make sense to everybody? If If the last two didn't make sense, then you probably want to review your laws of logs. Okay. So for this guy, it's basically you just plug and chug. Everywhere you see an X, you replace it with a 64. The only thing I'm going to do is actually just switch the order for this. So kind of how you would read it, you would probably do X squared and then the cube root. I'm going to do it as the cube root squared. And they're both the same thing because both of them are equal to X to the 2/3. Cool. So now I have f of 64 is equal to 5 times the cube root of 64 squared minus 24 over the square root of 64. What is the cube root of 64? So 64 is
4.
exactly. So this guy right here is 4. So 4 squared is 16. What's the square root of 64?
8.
Exactly. So I get 5 times 16 minus 24 over 8. So that's 80 minus 3 is equal to 77. Does that make sense to everybody? Cool. So we've got this guy, this parabola, and we want to find the vertex. And answer, is the vertex the highest or lowest point on this graph? So first thing first, actually, I guess second things first, is this guy going to be the high, first off, is this parabola going to look like this guy or like this guy?
It will open down.
Yeah, it's going to be this one because the lead coefficient is negative. So if the lead coefficient is positive, then we get this guy. If the lead coefficient is negative, we get this guy. And if it's opening down, then that means that it's actually going to be the highest point. So it is the highest point. And now, do you guys know the formula for the x value of the vertex of a parabola? Hint, it's pretty similar actually to the quadratic equation. So that was never to be plus or minus the square root of b squared minus 4ac all over 2a. So it's going to be the midpoint of these two things. And if it's the midpoint and one of them you're adding something and then the other one you're subtracting something, then you can basically just eliminate that. And we get it's negative b over 2a is the formula for the vertex. So that gives us negative 8 divided by negative 2 times 2. And that's going to be equal to negative 8 over 4 equal to 2. And now I just plug in 2 to this equation. So f of 2, to get my y value, f of 2 is equal to negative 2 times 2 squared plus 8 times 2 plus 11. So that is going to be equal to negative 8 plus 16 plus 11 is equal to 19. So my vertex occurs at
219.
exactly. So 219. Cool. And again, that is the highest point. Clear all drawings. Okay. So if I find the domain of this guy, the function is clearly defined between -3 and -6. Is like it's not defined anywhere outside of there. So the domain is some subset of -3 to 6. The only question I have to ask, is there any point in the middle here where it's not going to work? So I'm going to take a look at each of these equations, and then I'm going to take a look at the boundary zones. So is there anywhere on the entire real line where -x plus 2 would not be defined?
No.
Yeah, because lines are defined everywhere. What about x squared plus 1? That's parabolas are also defined everywhere. You can plug in any number and you'll get a valid answer out. And g of x equals 5, also the same thing. Technically that's a line, horizontal line. We tend to think of it more as just a constant, but that's defined for everything. So it's not going to be broken on anywhere in the middle of these intervals. Now I only have to check, is it defined on all of the boundaries? And the answer is going to be yes, because on the boundary, it's defined as 0 or 4, 0 here, and then it's defined on the boundary for 2 here. The only thing I want to make note of is that, so 2, 6, let's say, and 2, 6. The difference between these brackets are inclusive, parentheses are exclusive, meaning that they don't include the endpoints. Does that whole explanation make sense to everybody?
Yes.
Cool. So a positive number to any integer value, doesn't matter if it is to an odd or an even, is going to be positive. So for both a and b, we're dealing with positive numbers. A negative integer or negative value raised to an odd integer is going to be negative. So -2 to the 1 would be -2. -2 cubed would be -8. -2 to the 5th would be -32. But if I were to raise them to even numbers, -2 to the squared is +4. -2 to the 4th is 16, blah, blah. So a negative number to any even integer is going to be positive. Does that make sense to everybody?
Yes.
Cool. So first off, what's the definition of domain and range? Somebody give me the definitions of domain and range.
Domain is all the applicable x values for an equation, and range is the all applicable y values for an equation.
Yeah, exactly. So the domain is any number, any value, typically of x, but it's just whatever domain you're mapping or whatever area you're mapping from, whatever values you can validly enter. And then the range is whatever values that this function will actually hit. So e to the x, what is the domain of that guy? Is there any real number that I can plug in that wouldn't work? Look something like this, right? Is there any value that I can plug in? Any real number that would make this break?
No, not for F.
Yeah, so that just means that the domain is negative infinity to infinity. So the domain is negative infinity to infinity. And then it's actually going to be the same thing for e to the negative x, because actually I'll change colors for this guy. E to the negative x basically just looks like the mirror image of e to the x. What about the range? What numbers can e to the x and e to the negative x hit?
0 to infinity.
Any number below 0, 0 to infinity.
Well, any number below 0?
It wouldn't be equal to any number below 0.
Yeah, so it can't hit that, but what can it hit? So I guess,
0 to infinity.
and how am I going to write that? Am I going to have a parentheses or a bracket?
Parentheses.
Yeah. You could also think of it as r minus 0, or sorry, that would be negative infinity to 0. But this is how we generally write it like this instead. So yeah, it can hit any non-negative number. You can never go small enough to actually hit 0 or go below the 0 line. Make sense? Cool. So find f and g such that h of x is equal to f of g of x. So there's actually infinitely many different ways you can do this, but there is one very natural way to do this. What is that very natural way?
You say that f of x is the square root of x and g of x is x squared minus 2x minus 3.
Exactly. Perfect. And the reason that you want to use the natural one as opposed to any of the other ones, or the trivial one, because f of x is equal to x and g of x is equal to square root of x squared minus 2x minus 3. This is also technically true, but it's very uninformative, so don't do this. That's the trivial one, or one of the two trivial ones. You can also switch the order there. Is that when you come to doing chain rule stuff in calculus, you're really going to want to be able to identify the natural function composition, a natural way to view it as a function composition. Okay. So if I want to draw a parabola, a parabolic function, what are some of the values that I care about?
Vertex.
What'd you say?
You should care about the vertex or the highest or lowest point of this parabola.
Yes, the vertex is very important.
X-intercepts.
Yeah, x-intercepts. And those are the most important ones, but there's one other one that is very nice to have as well.
Y-intercept.
Exactly. I'm going to so let's solve the y-intercept first, because that's the easiest. So that is literally just m of 0 is equal to 0 squared minus 2 times 0 minus 3, right? So m of 0, or the y-intercept, is equal to -3. So that is my y-intercept. What about my vertex? So what was the formula that we used before for the x value of the vertex?
-b/2a.
Yeah. So we have -2 divided by 2 times 1. So that gives me so that gives me just 1. And now if I plug in 1 into this equation, I get 1 squared minus 2 times 1 minus 3. So that is equal to -4. So 1, -4 is another point on this equation. And then how am I going to find the x-intercepts?
Factor.
Cool. So how am I going to factor this guy? Two things that multiply to give me -3 and add to give me -2. So that's going to be 3 and 1. And then the bigger one has to be negative because this guy is negative. So I get x minus 3, x plus 1. And that tells me that the x-intercepts are going to be equal to x's are going to happen at x equals 3 and x is equal to -1. So x equals -1 and x is equal to 3. And then I'm just going to use the fact that this is a mirror image to plug in that point as well. And that is basically what the drawing the graph of this parabola will look like. Does that make sense to everybody?
Yes.
Cool. So unless you guys have any other questions, you are free to go 8 minutes early.
I have a question about how the open-ended exam parts work.
Yeah, so the written section on the exam, you're going to be posting it onto the recitation section, if that is what you mean, or if
Well, I don't understand how, when we head over to do the midterm or the exam, how would I post a recitation? Well, the open-ended part.
So basically what is going to happen is you are going to submit what's it called? You just submit either a PDF or you can take pictures of it and paste it into a Word document for the written section. And then you're going to upload that. I'm going to create an assignment on the Blackboard page that you will upload it to. But I believe you will also have multiple choice and stuff like that you will answer separately.
Okay, thank you.
Does that make sense?
Yes.
Cool. In that case, everyone have a nice day.